students, in the last session we have completed first 5 questions from 3.5, right? In theory of equations we finished exercise 3.5, the first 5 questions. Today we are going to do the remaining sums, question number 6 and 7. See the question now. Question number 6. Find all real numbers satisfying 4 power x minus 3 into 2 to the power x plus 2 plus 2 power 5 is equal to 0. For doing this one, first we are going to rewrite this 4 as 2 square. So 2 square into x. This 2 power x plus 2 we can write 2 power x into 2 square. Then simplifying means we will get one quadratic equation. Okay, let's see the question now. This 4 means 2 square the whole power x minus 3 into 2 to the power x into 2 square. This 2 power x plus 2 can be written as 2 to the power x into 2 square plus 2 power 5 is equal to 0. Now this 2 square, the square we are taking into the outside. So 2 power x the whole square. We are interchanging this x and 2. Reason is a to the power m the whole rest n is a power mn. The same like a to the power n the whole power m is also a to the power mn. So both are same. Minus 2 square 4, 4 3s are 12. 12 into 2 to the power x plus 2 to the power 5, that is 32, which is equal to 0. 2 to the power 5 means 2 into 2 into 2 into 2, that is 32. Now we are giving another variable for this term 2 power x. Let y is equal to 2 power x. If you are taking y is equal to 2 power x, it will become y square minus 12 into y plus 32 is equal to 0. We got one quadratic equation, right? Quadratic equation in y. So product 32, sum is minus 12. Find two numbers whose product is 32 and whose sum is 12. The possible numbers are minus 4 and minus 8. Minus 4 minus 8, 4 8s are 32. Minus 4 minus 8 is minus 12. So we can write this as y minus 4 into y minus 8 is equal to 0. So product of two terms equal to 0 means either the first term 0 or the second term 0. That is y minus 4 is equal to 0 or y minus 8 is equal to 0. That is y is equal to 4 or y is equal to 8. But what is y? Y means 2 to the power x. So replace this y by 2 to the power x. 2 to the power x is equal to, this 4 can be written as 2 square. Likewise y, what is y? 2 to the power x, which is equal to 8 means 2 cube. See, 2, 2, the base elements are same, so we can equate the power. When we are equating the power, we will get x is equal to 2. In this equation, if you are equating the same means, we will get x is equal to 3. So the solution is x is equal to 2 and x is equal to 3. See the next question, question number 7. Solve the equation 6x raised to 4 minus 5x cube minus 38x square minus 5x plus 6 is equal to 0 if it is known that 1 by 3 is a solution. So it is given one of the solution of this equation. One solution of this equation is 1 by 3. But if you are looking this equation, it is of the type 1. Type 1 of reciprocal equation of even degree. So this equation is type 1 form of reciprocal equation of even degree. That means 1 by x is a solution means, one solution means x is also a solution, or 1 by a solution means a is also a solution. A solution means 1 by a is also a solution. So in this case, what is given? 1 by 3 is a solution. That means 3 is also a solution. So from the two solutions, we can form one quadratic polynomial. So with the quadratic polynomial, we can get the other polynomial also. Reason is it is of degree 4. So we can rewrite this fourth degree equation as the product of two quadratic polynomials. Then solving the two polynomials will get the answer. Okay? So given that 1 by 3 is given, 1 by 3 is a solution of the given equation. This given equation is in type 1 reciprocal, type 1 reciprocal even degree equation. So 1 by 3 solution means 3 is also a solution. Therefore 3 is also a solution, of equation 1. Let it be equation 1. If 3 and 1 by 3 are two roots means we can find one quadratic polynomial, right? As a factor of the equation 1. Therefore, x minus 1 by 3 into x minus 3 is a factor of equation 1. When we simplify, before simplifying, multiply this equation with 3, so we get 3x minus 1. When we multiply 3x, here 3 cancel, okay? Into x minus 3 is a factor of equation 1. Both are same. Again, if you are simplifying, means 3x into x is 3x square, minus of minus plus, 3 into 1 is 3. Now the middle term x term, 3x into 3 is minus 3x, minus 1 into x is minus x, so minus 4x, right? So 3x square minus, 3 3s are 9, 3 3s are 9, x into constant, constant into x, 3 3s are 9, minus 9x minus 1x, that is minus 10x. So when we are simplifying, we will get x square, 3x square minus 10x plus 3 is a factor of equation 1. So the given fourth degree equation, can be written as the product of this quadratic polynomial into product of another one, that is 6x raised to 4 minus 5x cube minus 38x square minus 5x plus 6, which is equal to product of this one, this quadratic polynomial, 3x square minus 10x plus 3 into another polynomial. When we are multiplying the second polynomial with the first one, we need to get the original equation, right? That means when you are multiplying first and first, we need to get the 6x raised to 4. So the only possible term of the first term is 2x square. Then only 3 2s are 6. X square and x square is x raised to 4. Likewise, when we multiply last and last, we will get the last term. So the only possibility is 2. Reason is 3 2s are 6. The middle term we can predict as px. Now our aim is to find the value of p. How can we find the value of p? By equating the coefficient of x on both sides. When we are equating the coefficients, equating the coefficient of x, this side we have minus 5. When we multiply x with the constant and the constant with the x, we will get x term. All the other time we will get x cube, x raised to 4 and constant term. But we need only x term. So x term is obtained by multiplying constant and x and constant, constant and x. So 2 into minus 10 is minus 20. 3 into p is 3p. Bring this minus 20 that side. So 3p is equal to minus 5 plus 20. That is 3p is equal to 15, 5. That means we are getting p is equal to 5. If the value of p 5 means, we can get one new equation, right? This equation. Therefore, 2x square plus p is 5. 5x plus 2 is equal to 0. Now, from this equation, we will get 2 more roots. 2 2s are 4, product to 4, sum 5, so 1 and 4. We are having numerical coefficient of the square term, so divide the same. 2 2s are 4. So we can write the factors directly, that is x plus 1 by 2 into x plus 2. That is x is equal to minus 1 by 2, x is equal to 2. Already we have 3 and 1 by 3, right? Therefore, the solutions are x is equal to minus 1 by 2, 2. The beginning we have two values, that is 3 and 1 by 3. 3 and 1 by 3. Therefore, the solutions are minus 1 by 2, 2, 3, 1 by 3. Here we have minus 2, right? So minus 2. Minus 1 by 2, minus 2, 3 and 1 by 3. It's clear? Now we are having the last exercise 3.6. See the first question. Discuss the maximum possible number of positive and negative roots of the polynomial equation 9x raised to 9 minus 4x raised to 8 plus 4x raised to 7 minus 3x raised to 6 plus 2x raised to 5 plus x cube plus 7x square plus 7x plus 2 is equal to 0. Here we are going to use the sign changes of the coefficients. The number of sign changes gives the number of roots. Suppose if we take this equation as 1p of x, find the sign changes of p of x. Suppose if you are getting two changes in sign, then we can say this equation has only 3 positive roots. Then find the sign changes of the coefficients. when we apply x is equal to minus x. When we are applying x is equal to minus x, again we have to find the number of sign changes. Suppose if it is 2, then we can say this equation has only 2 negative roots. Okay? Here the question is what? Just we have to discuss the possible number of positive and negative roots. No need to find the roots. Okay? So we are finding the number of positive and negative roots. So clear? Okay. Now first we are going to take this equation as one p of x. So let p of x is equal to 9x raised to 9 minus 4x raised to 8 plus 4x cube x raised to 7 minus 3x raised to 6 plus 2x raised to 5 plus x cube plus 7x square plus 7x plus 2. Now the sign changes. See the sign of the coefficients. The sign of the coefficient of p of x. Here we have plus, so plus, here minus, plus, minus, remaining plus, plus, again plus, plus, plus. See the sign changes now. Plus to minus, yes, one change. Minus to plus, again one change. Plus to minus, one change. Minus to plus, one change. Here there is no change of sign. Change of sign means either negative to positive or positive to negative. If the sign is changes from positive to negative or negative to positive, then we can count 1. Here there are 4 changes, right? There are 4 changes. Therefore, there are 4 sign changes. That means this p of x has only 4 positive roots. Therefore, p of x has 4 positive roots or positive solutions. Now we are going to find out p of minus x. P of minus x. P of minus x. That means we have to replace all these x by negative sign. So 9 into minus x the whole power 9 minus 4 into minus x the whole power 8 plus 4 into minus x the whole power 7 minus 3 into minus x the whole power 6 plus 2 into minus x the whole power 5 plus minus x the whole cube plus 7 into minus x the whole square plus 7 into minus x plus 2. We know minus the whole power even number is positive, right? Minus the whole power odd number is negative. So here we'll get minus 9x raised to 9. Minus the whole power even number is positive. So this is positive, but here we have minus. So minus 4x raised to 8. Minus the whole power odd number is negative. So minus 4x raised to 7. Minus the whole power even number is positive. So this is positive, but here we have minus sign. So minus 3x raised to 6. Minus the whole power 5. 5 is an odd number. So minus 2x raised to 5. Here also odd. So minus x cube. Here minus the whole power 2 positive. So plus 7x square. Here minus 7x plus 2. Now let's check the changes of sign. See the sign of the coefficient of p of minus x. Minus, 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 then plus, minus, Here there is no change in the sign, but here see minus 2 plus 1 change, plus 2 minus again 1 change, minus 2 plus 1 change. That means only 3 changes, right? So there are 3 sign changes. That means P of x has 3 negative roots. So P of x has 3 negative roots. But this equation has degree 9. Here we said 3 negative roots and 4 positive roots. So 3 plus 4, 7. Remaining 2 roots, right? The remaining 2 roots are maybe imaginary. So the given equation has 4 positive roots and 3 negative roots. It is of degree 9. So 9 minus 7 is 2. Degree is 9, no? So here 4 plus 3 is 7 roots. Remaining 2 roots may be imaginary. But that thing no need to discuss. Reason is, the question is what? We have to discuss only the number of possible positive and negative roots. Is it clear? See the next question. Discuss the maximum possible number of positive and negative zeros of the polynomial x square minus 5x plus 6 and x square minus 5x plus 16. Also, draw rough sketch of the graph. So, first we are trying to find out the possible number of roots. Okay? Let P of x is equal to x square minus 5x plus 6. Now, first we are going to check the sign changes, right? The sign of P of x. The sign of coefficient of P of x, that is plus, minus, plus, plus, minus, plus. So plus 2 minus, minus 2 plus, 1, 1. There are 2 changes. There are 2 sign changes. That means P of x has at most 2 positive roots. We know every nth degree equation has n roots. Here the degree is 2. So here we got 2 positive roots. Suppose if you are checking P of minus x also, no problem. When we check P of minus x, that is we want to replace x by minus x, right? So minus x the whole square minus 5 into minus x plus 6. That is equal to minus the whole square is positive. So x square minus half minus plus 5x plus 6. So what about the sign changes? The sign changes. See, plus, plus, plus. So there is no changes, right? There is no change of sign. That means there is no negative roots. It is same like the next equation also. Reason is the next equation, see the next equation, x square minus 5x plus 16. The only changes is the constant term. So this equation, there is no change in this equation. It has 2 positive roots only, right? Now we are going to draw the diagram. x-axis, origin, y-axis, 1, 2, 3, 4. 1, 2, 3, 4. When we solve the first equation, see x square minus 5x plus 6. The roots are 2 and 3. So, the curve passes through 2 and 3, the point 2 and 3. It may be like this. So, this is the equation x square minus 5x plus 6 equal to 0. So, this is the graph representing x square minus 5x plus 6. But what about the next graph? X square minus 5x plus 16. That is here is the origin 1, 2, 3. This equation x square minus 5x plus 16, there is no factor for 16, right? See, is it possible to find the two numbers whose product is 16 and whose sum is minus 5? There is no such number. That means there is no real solution for this equation. But if we apply x is equal to 0, we will get y. Y is equal to 16, maybe here 16. So it will cross y-axis at 16, but we can't say where it will cross the x-axis. It will not cross x-axis. So it may be like this. That is x square minus 5x plus 16. Now come to question number 3. Show that the equation x raised to 9 minus 5x raised to 5 plus 4x raised to 4 plus 2x square plus 1 equal to 0 has at least 6 imaginary solutions. So let us take the given equation as p of x is equal to x raised to 9 minus 5x raised to 5 plus 4x raised to 4 plus 2x square plus 1. Now, the sign of p of x, see, plus, minus, plus, plus, plus. See the change of sign, plus to minus 1 time, minus 2 plus 1 time. Thereafter there is no sign change. So only 2 changes, right? Therefore, number of sign changes of p of x are 2. That means this equation p of x has only 2 positive roots. Therefore, the equation has at most 2 positive roots. Now, let's check for the negative roots. For that, first we need to find p of minus x. So, what is p of minus x? P of minus x is obtained from p of x by replacing all the x by minus x, right? So, we will get minus x raised to 9 minus 5 into minus x the whole power 5 plus 4 into minus x the whole power 4 plus 2 into minus x the whole square plus 1. Minus the whole power odd number is negative, so x raised to 9. Minus the whole power odd number is negative, so minus or minus plus. Minus the whole power even number is positive, so 4x raised to 4. Here, minus the whole power even number is positive, so 2x square plus 1. Now see the sign, minus, plus, plus, plus plus. So only one sign change, minus to plus. That means there is one change. There is one change in sign. Therefore, the equation P of x has at most one negative roots. So already we got two positive roots, right? Here one negative root. So total there are three real roots, right? Therefore, the equation P of x has three real roots. But the degree of P of x is 9. Degree of P of x is 9, but it has only 3 real roots. So 9 minus 3 is 6. That means it has 6 imaginary roots, right? See, 2 positive roots, 1 negative root, so total 3 real roots. The degree of the equation is 9, so it has 9 roots, but here we find out only 3 real roots. So the remaining roots are imaginary. Therefore, the equation P of x has at least 6 imaginary roots. We find out 3 roots only. The degree is 9, so it has 9 roots. The remaining 6 roots are imaginary, right? Now come to the next question, question number 4. See question number 4. The same question only. Determine the number of positive and negative roots of the equation x raised to 9 minus 5x raised to 8 minus 14x raised to 7 is equal to 0. Let us take this equation as one P of x. So let P of x is equal to x raised to 9 minus 5x raised to 8 minus 14x raised to 7. Now the sign of P of x is plus, minus, minus. So only one change, right? So there is one change of sign or one sign change. That means the equation P of x has at most one positive root. One positive root. Now we can go for the negative roots. For finding the negative roots, we need to find P of minus x. P of minus x means we want to replace all this x by minus x. So when we are replacing x by minus x, we will get minus x the whole power 9 minus 5 into minus x the whole power 8 minus 14 into minus x the whole power 7. Minus the whole power odd number is negative, so minus x raised to 9. Minus the whole power even number is positive, so no change here, but already here we have minus, so minus 5x raised to 8. Minus the whole power odd number is negative, so minus or minus plus, that is 14x raised to 7. Now see the sign of P of minus x, that is minus, minus, plus. The sign of P of minus x is equal to. So here only one change, minus to plus. There is only one sign change. That means P of x has at most one negative root. So this equation P of x has one positive root and one negative root. Now see the next question. Find the exact number of real zeros and imaginary of the polynomial x raised to 9 plus 9x raised to 7 plus 7x raised to 5 plus 5x cube plus 3x. Find the exact number of real and imaginary roots, right? So we are going to take this as one P of x. The sign of P of x all are positive, right? That is C plus 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 plus. There is no change. There is no change of sign. Therefore, P of x has no positive zeros. Why we are using this word zero means it is given the polynomial, not a equation. Equation means we can use roots. For polynomials we can use the word zero. Okay. Now we can go for P of minus x. So what is P of minus x? P of minus x means minus x the whole power 9 plus 9 into minus x the whole power 7 plus 7 into minus x the whole power 5 plus 5 into minus x the whole cube plus 3 into minus x. Now see the sign of P of minus x. Minus the whole power odd number is negative, so minus x raised to 9. Minus the whole power odd number is negative, so again minus 9x raised to 7. Here also odd power, so minus 7x raised to 5. Again here also negative power, so minus 5x cube minus 3x. Now check the sign of P of minus x. The sign of P of minus x are minus, 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 minus. Here also there is no change. There is no change of sign. That means P of x has no negative zeros. Right? But if we apply x is equal to 0, what will happen? If we apply x is equal to 0, you will get to 0, right? That means x is equal to 0 is a 0 of this polynomial. But x is equal to 0 is a 0 of the polynomial P of x. So here we have no positive root, no negative root, but it has one root which is x is equal to 0. But the degree of the polynomial is 9. The degree of P of x is 9. But here we get only 1 0, right? So 9 minus 1 is 8. That means the remaining 8 roots are imaginary. Therefore, the remaining 8 zeros are imaginary. See, we have no positive root, no negative root, but 0 is a solution. That means the degree is 9, So getting only 1 0. 9 minus 1 is 8. That means the equation, not the equation, the polynomial. The polynomial has 8 imaginary zeros. Okay, there is no real zeros, only imaginary zeros. Okay, is it clear? So with this we completed chapter 3. In the forthcoming session we will discuss chapter 4. Okay, thank you.